How's it going, missing in action Algebra 1 students? It's your host, Mr. Knight. We are going to be continuing on with factoring, and we're going to look at a new method of factoring today, and we're going to learn how to factor something called a difference of two squares. So looking at this example right here, let's talk about why it's called a difference of two squares. Well, difference meaning we're subtracting, and we have two squares right here. What do I mean by that? Well, I mean that we are taking them to the second power, right? This x is being squared, and 25 is also something that's squared. What number would that be? Well, that would be 5. 5 squared is really what 25 is, and we take the difference between those two, hence difference of two squares. And we can actually factor that in a pretty straightforward way. But let's take a minute to actually go over here and review multiplication of binomials, aka foiling. It's going to come in handy in a bit. Okay. So when we are doing foiling, remember, we take our first term and we're going to distribute it or multiply it to both of these terms. And then once we're done with that guy, we handle the second term and do the same thing. Right? If I multiply these, x times x is x squared. X times negative a is a minus ax. We got a times x, which is a positive ax. And a times negative a, which is a minus a to the second power. Now, looking at this result that we have, what do you notice about these middle terms? Well, they're like terms, and more importantly, they are opposites. They actually cancel each other out. So our answer that we get is actually x squared minus a squared. Now, what we could say is that this is equal to what we had originally. We had x plus a times x minus a, and we ended up getting this as our result. Now, why is that important? Well, if I look over here, this actually matches up identically with this x and this a right here. And so in order to actually factor a difference of two squares, we actually can put it in this form right here. So this is going to be my x, of course, and this is going to be my a. So if I want to factor x squared minus 25, well, that's going to be equal to, well, my x is here and here. So let me open up my parentheses. X here, and my a is 5, so 5 will go here, 5 will go here, and finally I need a plus here and a minus here, and there we go. This guy is factored. This guy is in factored form, and I factored the difference of two squares. So that's all there really is to it. So let's go ahead, let's look at the note sheet now, and let's continue on with that just a bit. All right, so we already did the review. So we're going to go ahead and skip that, and we're going to get straight to the result, what we just got. So instead of using x squared minus a squared, we're instead just going to call it a squared minus b squared. Again, a is just corresponding to this, this first term right here, and b is going to correspond to this second term. Okay? So really what we end up getting is our a plus b times our a minus b. And that's all there is to it. Now, the tricky part with this might be recognizing what your numbers are when they're squared. So, for example, let's start off with number 2 right here. Okay. Well, I can write this guy, this n squared minus 64. I can represent this as my n going to the second power. And I can also represent this 64 as a squared term. So basically, what times what is going to give me 64? Well, it's got to be 8. So that would be 8 squared. Okay, I have my A, I have my B. And so now, if I want to actually factor this and complete the problem, then I'm going to be turning it into this guy. So my A was my N. So N goes here for A. And then for B, it's my 8. So 8 goes here, 8 goes here, and I need my plus and my minus. and that guy is factored and done. And that's all there is to it. Now, as a way to check and see if you're doing this correctly, you can actually FOIL this back out, and, well, you should end up getting n squared minus 64. Let's go ahead and do that. N times n gives me n squared. N times negative 8 is negative 8n. 8 times n gives me a positive 8n. 8 times negative 8 gives me minus 64. And as you saw in that previous example at the very beginning, these guys will cancel out, and so I'm left with n squared minus 64, which is what I had originally. So it checks out, and this would be our correct result. And that's really all there is to it, is breaking these numbers or variables down into squares, and then just kind of plugging them in where they go. So let's try it again with something like number 6. All right, I have 1 minus 49y squared. So I got this variable with this guy too. Again, let's see how I can represent that. Well, I can represent this 1 as 1 squared. 1 times 1 is 1. Minus, well, I have a 49. So what times what gives me 49? It's got to be 7. And y times y gives me y squared, so I need to include just 1y right there. And that whole thing would be squared. My apologies. So now I have my a, I have my b. So putting this all together, if I have my parentheses, my a was my 1, my b was my 7y, and I need my plus, my minus, and I am done. Okay, that's all there is to it. Let's try another one. Let's do something like number 14. All right, 14. 81n to the 4th minus 25. Let's make these guys into squared forms first to get our a and our b. So, what times what gives me 81? Well, that's got to be 9. And then, what times what gives me n to the 4th? Well, that's got to be n to the 2nd power. N to the 2nd power times n to the 2nd power gives me n to the 4th. So, that would be my a term. And I can also represent this 25 as 5 squared. So once again, I have my a, I have my b. So my answer, if I'm plugging all this in, my a's are going to go here and here, 9n squared, 9n squared, plus, minus, and then my b is my 5. And that guy is my factored form, this difference of 2 squares. Okay, let's go ahead, let's flip it to the back. All right. Let's look at something like 15 real quick. This guy right here. Now, I have 4c squared minus 5d squared. All right, well, I can represent 4c squared. I know what times what equals 4. That's 2. And I know c times c will give me c squared. So 2c would be my a term. So I can represent that as a square. Now, what times what is going to give me 5? Well, it turns out we don't actually have anything. And while d times d will give me d squared, because I can't actually do anything with this 5 and represent it as a squared term, I can't do anything to this guy, so actually this guy can't be factored. So be aware of that. They're not guaranteed to be factorable necessarily, so be vigilant when you're doing that. Let's go ahead, let's do some multi-step factoring now. So what we're going to do is we're going to look for a GCF first. Then we're going to factor the difference of squares. Okay. So again, with our GCF, we're trying to see what's the biggest number that can go into our coefficients. And then we also want to see if there's a variable in common with each term. If there is, we'll pick the one with the lowest exponent, and that'll be our GCF. Okay. Let's start with 21. Well, 24 and 54, what's the GCF of that guy? What's the biggest number that can go into those? Well, it turns out it is 6. 6 ends up being the biggest number that can go into those. All right. And, well, I can't actually factor out an A or a B because they're not in common with both. So 6 is my GCF. I'm going to go ahead and divide both of those terms by 6. So I end up getting 4A squared minus 54 divided by 6 is 9B squared. Okay, now I'm going to look at this part right here, and I'm going to do the difference of two squares. This 6 is going to be chilling on the outside the whole time. I can't forget him when I write my factored form out. Okay, so let's see if I can represent this purple part again into a difference of two squares. Well, 2 times 2 equals 4. So I'll write my 2 in there. And then A times A equals A squared. Minus 3 times 3 is 9. B times B is B squared. So there's my A. That's my B. So putting all this together, using my A plus B and my A minus B, this is going to be 2A plus 3B times 2A minus 3B. And I can't forget my 6 that was chilling on the outside right here. So that would be my factored form of this guy right here. Okay, so it can get a little bit more complicated if we include the GCF. So maybe let's get a couple more repetitions down with that. Starting with, let's do 25. 25, let's start with the coefficients. 136. What's the biggest number that can go into those guys? Turns out it is 4. 4 is the greatest number. Now, do they have a variable in common as well? They do. They have a b, and b to the first power is the smallest one. So that's my GCF. Let's go ahead and divide each of these guys by 4b. 100 divided by 4 is 25. B to the third divided by B to the first is B to the second. 3 minus 1 is 2. Minus, well, 36 divided by 4 is 9. B divided by B is 1, so they cancel out. So here we go, factored with the GCF. But now, let's see if we could factor a difference of two squares. Can I represent those guys as a difference of two squares? And it turns out I can. 5 times 5 gives me 25. So 5 squared works. B times B gives me B squared. And then finally this guy, 3 times 3 gives me 9. So 3 would go here. I have my A. I have my B. So putting it all together, I have A plus B. So 5B plus 3. And I also have that multiplied by 5B minus 3. And of course, I factored out a 4b in the beginning, so that guy has to go next to this result, and that would be my factored form right there. As gross as it looks, it is technically correct. All right, this is Mr. Knight signing off. Go ahead and review those examples if you need to, and again, a lot of it is if you can represent it. If you can represent it as a difference of two squares and you find your A and B, the rest of it is just plugging it into this little form right here. Okay? Have a good one. Good luck. You got this.